All right, guys, where were we? Remember, it's just easier to download two smaller pieces. So this is section 8.3, part 1. We're going to finish up part 1, okay? And we were doing the comparison test. We had just written the comparison test. Now let's actually put it into place, okay? So what do we mean by this? Remember, we're going to choose this one on our own. It's usually a p-series or a geometric series. And then this is the given one. If this guy converges and this is smaller, then this guy converges. If this one diverges and this one is even bigger, then this one diverges. Okay. All right. So let's take a look. What are we talking about? Okay, I think those can go there. Let's get some directions up. Let's see if we make sure we can see here. Use a comparison test to determine whether the series is convergent or divergent. Okay, and let's put up a problem. Summation of n equals 1 to infinity, okay, of 5 over 2n squared plus 4n plus 3. Okay, all right, so we're trying to decide if that converges or diverges, okay? A couple of things about that one, okay? Now, first of all, and this is where it gets kind of tricky. It's like, okay, I'm telling you to use the comparison test, but what about my other tests out there? So let's just talk about it for a minute, okay? Where did I put that? Okay, so if, this is kind of like the telescoping, okay? The only thing with the telescoping is that this would have to factor. This would have to factor, and we'd have to be able to come up with two fractions, okay? So it's very, right, and those two fractions have to kind of start canceling out each other out. They kind of have to be, I don't know if we want to say related, but this would be one where you could think at least telescoping, but those have to be very, very specific. All right, now the other thing, don't forget what's out there, is the test for divergence, okay? And this says to take a look at the limit. You don't have to write this down, but just so that you see. Don't forget about the test for divergence. It says take a look at the limit as n approaches infinity of this guy, okay? And this is what I was talking about earlier. Let's see if I have that. Oh, I just had you. Okay, here it is. All right, so the test for divergence says take a look at the limit of this guy. And that's what I was kind of talking about here. That's the horizontal asymptote. We can't, for this one, do L'Hopital's rule. We cannot do L'Hopital's rule because we don't have infinity over infinity. So the long way would be to divide everything by n squared, okay? This would be the long way, right? We would have 5 over n squared, and then we would have 2n squared, it doesn't matter, over n squared, all right, plus 4n over n squared. And again, you can just watch. You don't have to write this down. Over n squared, okay? Or, this is what I was getting at, and then simplify, right? Or you can just kind of, instead of doing that, or L'Hopital's rule, but in this case, his doesn't even work, we could just memorize these two things. If the bottom exponent is bigger, right, this is an n to the 0, doesn't even exist, this is an n squared. If the bottom exponent is bigger, the limit is 0. Okay. Or now, like since we did this, we could see that this top would be going towards 0 and the bottom would be 2. We would have 5 over n squared, and this would be 2, 4 over n plus 3 over n squared. Okay. It's a good review of the, what is it, test for divergence. Okay. And this would get bigger and bigger and bigger, so this would head to 0, but we do have the 2 on the bottom. These guys would head to 0, and so we would have 0 over 2, which equals 0. But otherwise, if we just memorize this, and we say, hey, the bottom exponent is bigger, I automatically know that the limit is heading towards 0 because of all of this. Okay, but I'm just kind of taking the shortcut. All right, that's what I was talking about there. Okay, and then to top it all off, okay, where were we going with this, right? If I do the test for divergence and it equals 0, I'm back to the drawing board. Okay, so what was the first? Oh, telescoping, very isolated. It might work here, but the pattern has to be perfect. The test for divergence ends up being 0, which doesn't help me out at all. So what will help me out? Okay, so here we go. So here's the comparison test, but I kind of want you to see how all these like kind of start to overlap, and you kind of have to think about different ones at different times. Okay, so let's take a look. I'm just going to rewrite it. We're going to specifically use the comparison test. Let me rewrite this one more time. You don't necessarily have to. 5 over 2n squared plus 4n plus 3. Okay, so let's actually do now this new one. We kind of proved that we're out of tests, right? Telescoping this wasn't perfect for telescoping. It didn't pass the test for divergence. So now let's take a look at the comparison test. Okay, so we need a benchmark. We need to pull something out of thin air. And we are good at this. Okay, so the benchmark, we're going to call it B sub n. Okay, and usually what we do is we just take the first two. We just make it smaller. We just make it similar. Oh, make sure you can see. So my benchmark is going to be 5 over 2n squared. And that, we'll keep working at this. Kind of what are we going to come up with a benchmark? I think you'll kind of see a pattern or an idea. Okay, so now we want to take a look at this. This is A sub n. Actually, let me mark that. This is A sub n, and this guy is now B sub n. Okay, that one I labeled. Okay, so we need to take a look at 5 over 2n squared plus 4n plus 3 and 5 over 2n squared. Okay, those are our two things. Let's take a look at this guy. We need to know whether this converges or diverges. So let's take a look. We're going to do this, n equals 1 to infinity. We're going to take a look at this guy, okay? Because we need to know whether this converges or diverges. Okay, let me rewrite this. N equals 1 to infinity. I'm just going to rewrite this as 5 halves. So we have a number, we don't care about that number, and then times 1 over n squared. Okay, this is a p-series. Get that here. This is a p-series. Remember, our benchmarks are usually geometric or p-series. This is a p-series. We don't care about the 5 halves, we care about this guy. What number is p? P is 2. P equals 2. If p is greater than 1, it converges. So my p is greater than 1, therefore it converges. Okay. All right. But we're not guaranteed. We have to do one more thing for the comparison test. All right. So it's a p-series. If my p is greater than 1, it converges. Okay. So if what I chose converges, this is what I chose, and it converges. Okay. And I have to show that this is always smaller or equal to this guy. Okay, so what does that mean? Well, let's think about it. Whatever number I have here, especially on the bottom, because my 5s are the same, whatever number that I have here, I'm going to add 4n to it and plus 3. What is that going to do to the denominator? That's going to make my denominator bigger. Okay, we could even plug in, like if we plug in a 2, right, then this would be 8. But here I'm going to plug in a 2 and I'm going to get 8, but then I'm going to get plus another 8 and plus a 3. And you can literally plug in numbers if you want. Plug in a 3, all right, that would be what, 18? But here the bottom would be 18 plus 12 plus 3. So If my bottom is bigger, if my bottom is bigger, the overall fraction is smaller. If the bottom is bigger, the overall fraction is smaller. So this will always be less than this. This is true. Okay. I need it. If it converges, I have to make sure the statement is true. If it's false, I'm done. I can't use this anymore. If it converges, this, my original, my A sub n must be less than my B sub n. I actually have to kind of think about that, and I really do have to make sure that it's true. Okay. Now, if that's true and this guy converges, then this guy converges. Okay. Let's see if I have a good way to write that. Let's write this. If B sub n converges, then my original problem, we could just write A sub n, or maybe then we could write the original problem. It's up to you. But the main thing is, if you just circle on your test converges, that's okay. So a lot of this test, unfortunately, is work. So we're gonna have to, I'm gonna really have to look at your work, which is not, it's just not good because we're gonna be kind of sending it back and forth, but I will be looking at your work. Then this converges. Remember, the bad thing is we have no idea what it converges to, but at least we know it converges. Okay. All right, let's try another one. Let's see, let's do this guy. All right, let me get, okay, yeah, okay, so let's do, make sure we can see here. Okay, let's do the summation from 1 to infinity, and we're going to do n over 2n cubed plus 1. Okay. We're going to do the comparison test. Okay, just keep in mind that probably not the best to do telescoping because I have the n up here. The only other one that would be out there, we could briefly try the telescope test, but the other one is, I don't know if I can find it, is that one, the test for divergence, the test for divergence. Oops, this is one. But remember, and that's just taking the limit, take the limit of this guy. Take the limit of that guy. If I try the test for divergence, I would take the limit of this guy. But what does my shortcut say? So here I could use L'Hopital's rule. If I take the limit, I could do L'Hopital's rule, or I could divide everything by n to the third. So if I want to try the test for divergence, I could do L'Hopital's rule. I could divide everything by n to the third, or I could use my shortcut, which says if the bottom exponent is bigger, the limit is 0. If I do L'Hopital's rule, I should get the limit is 0. If I divide everything by n to the third, I should get a limit of 0. And the problem is, if the limit is 0, no conclusions can be made. Or basically, I have to choose a different test. Okay, so I'm going to choose the test for comparison. All right, so what does that say? I have to come up with, on my own, a benchmark. What am I going to use for my benchmark? And let's go ahead and use that B sub n is going to be n over 2n to the third. Okay. All right, so this is my A sub n, and B sub n. My A sub n is n over, that's my given. The B sub n that I choose is going to be this guy. Okay, but when I'm working with, when I'm comparing, I'm probably going to use this. But this will simplify. That simplifies. I can also do it as, here I cannot cancel because I got this plus 1. But once I just choose my own and make it like this, I can simplify. The n's cancel, and so I have 2 over n squared. Okay. All right, let's take a look at this guy. The summation from 1 to infinity of, and I'm just going to rewrite this as 1/2 1 over n squared. Okay. What is this, guys? What is that? That's a p-series. Okay, you want to write, so that's what you're going to have to start writing on your test. You're going to have to start writing that you did the comparison test. Down here, it's a p-series. What's your p-value? Let's see if I have, here it is, p-series. If p is greater than or equal to 1, it converges. If p is less than or equal to 1, it diverges. Okay, my p is 2. I think that was the same it was last time. P is 2. Which is greater than 1. Is it greater than or? Yeah, it's greater than 1. Where did? Yep, greater than 1. So this converges. Okay, so I've proven that my benchmark converges. Now, if my benchmark converges, my only option is to prove that this guy is less than or equal to. Okay, so now I have to think about that. If this is not true, I cannot make any conclusions. Okay, I go to another test, believe it or not. Isn't that, it had to be, right? So we'll learn one more test. So if this is false, then I'm done. If this converges, it has to be less than or equal to. But take a look at it. Same thing as last time. Whatever this turns out to be, I'm going to add one more. Okay, which means my denominator is bigger. If my denominator is bigger, overall fraction is smaller. Okay, notice that the tops are the exact same. Okay, so I'm just comparing. If the bottom is bigger, the overall fraction is smaller. So this holds true. So if B sub n, what I chose, converges, okay, and this is true, then this guy converges. Okay, my original problem, this converges. Let's write this. If this converges, and we really should say, and A sub n is less than or equal to B sub n, because that is important. That has to hold true as well. Both of these things have to happen. Then we can say that converges. All right, let's try one more. One more. Okay. All right, let's take a look. Summation of n equals 2 to infinity. Remember, it doesn't matter that it's starting at 2. Can we see? N to the third over 3 n to the fourth minus 1. Okay. So it doesn't really hold now for telescoping anymore, especially because we have that n to the third. The test for divergence would be an option. Remember, the test for divergence is you take the limit of this. I could do L'Hopital's rule, I could divide everything by n to the fourth, or I could take my shortcut. The shortcut is end behavior. And if the bottom exponent is bigger, it's headed towards 0. The test for divergence says if it heads to 0, I've got no conclusion. Okay. I will tell you, and I'll put it up at the very end, this one, because it is 4 and this is a 3, you could actually do this with, believe it or not, the integral test. That's kind of the hard part. There's all these that overlap, and you got to decide whether it works or not. This one would actually work, and like I said, I'll just put it up at the end for you to see. But we're going to do the comparison test. I think it's, I don't know, maybe it's a little bit easier. But if for some reason on the test, unless I say use the comparison test, and for some reason you do integral test, you're fine. It doesn't matter. There is no right or wrong test. Okay. All right. So what is going to be my benchmark? What is going to be my benchmark? Let's take these coefficients. B sub n is going to be n to the third over 3n to the fourth. Okay. All right. So now n to the third over 3n to the fourth minus 1. That's a sub n. And then the one that I'm choosing to compare it with is this guy. Okay. This, we're going to use this form to compare it this way, but this reduces, right? This reduces, so I'm also going to look at it when I take the summation. I'm going to cancel out 3n's, so I'm going to have 1 over 3n. 3n's cancel with 3n's. Okay. I can think of this as 1/3 and 1 over n. Okay. P series, fine. You can do P series. My P is 1, so it diverges. Or what could we have said with this one? So you can write P series if you want. P series n is 1, or P is 1, it diverges. Or I could just say this is that special P series. This is harmonic. Harmonic, so it has to diverge. Okay. Or like I said, or if you want to write P series, P is equal to 1. If it is less than or equal to 1, it diverges. Okay. So you don't have to write both. Don't worry about writing both. If you see harmonic and you can just do harmonic diverges, that's what we're looking for. Okay. If you're just like, there's too many rules and I'm just going to always do P series, fine, no big deal. Okay. All right, so what does that tell us? This diverges. If this diverges, let me make sure I say it right. If this diverges, then this has to be bigger. If this diverges, now notice my sign is switching. But that's because this diverges. If this diverges, this has to even be bigger. Okay, so diverges, is this true? If it's false, I got nothing. I got another test coming up. Aren't you excited? But if this is true, then I'm done with the problem. Okay, so for diverges, notice, flip back my other symbol. I don't know if I have it. But when we did converges, we did it the other way. Okay, diverges, it's got to be this way. Okay, so what happens here? Everything's the same except I'm subtracting 1. Well, when I subtract 1, we can actually literally plug in a number, or we can just say, hey, if this is 7, this would actually be only 6, right? So if my denominator is smaller, my overall fraction is bigger. So this, because I'm subtracting 1, I'm going to make the denominator smaller, which means fraction is bigger. Okay, and like I said, if you want to plug in a 2 to the 4th times 3, right, we could do that. Here, 2 to the 4th times 3, but then minus 1, okay, would actually make this guy smaller. Okay, and you can even plug it into the top. If you literally want to plug in a couple numbers and even just divide it out and do decimal to decimal, you could definitely do that. Okay. If you want to take a look to make sure, you do have to make sure that this guy is bigger. Okay. Okay, so then this is true. That is true. So then if my P sub n diverges and A sub n is greater than B sub n, let's see, or equal to, it could be equal to, if B sub n is divergent and A sub n is bigger than B sub n, okay, then A sub n diverges, or we could write then the summation of my A sub n diverges. Okay. All right, so that is part 1. Okay, so try a few integrals and try a few comparison tests. Okay, and then part 2 will be the whole next lesson. So homework is just on integral and comparison tests, and they tell you which one to use. Oh, I know what I wanted to do. Then the next lesson is kind of where we start to have to do things on our own. Really yuck. All right, but remember I said, where was it? I said this, you could actually do the integral test. So let me at least put that up there. That is, so same problem. And let's see, does it fit? Oh, it just fits, so I can sneak it up too. This would actually be showing you have to do some u substitution, and that's why the 4 to the 3 works. because the derivative, the u substitution goes to x to the third. And then you can see that as you plug in bigger and bigger numbers, this is just going to get bigger and bigger and bigger. Okay, so if you want to take a look at that. So yeah, you can use a comparison test for this, or you can use, let's write integral tests. Okay. I think on the homework, I think it's going to be good to practice a comparison test. A comparison test comes up. I think on the other two problems, the integral test wouldn't have worked. It's just that this was literally one less. So when I took the derivative, the 4 to the 3, everything worked out. All right.